Hey everyone, so we are taking notes today. You should have a piece of paper and a pencil in front of you, just like how you would in class. Today's lesson is 7.1, Finding Square Roots. So go ahead and write that title down. Remember that you can pause the video at any time you want to be able to catch up if I go too quickly. So the last lesson that we covered was over square roots, but it was over perfect square roots. So we're going a little bit more in depth over all of the square roots that we could run into. And we're going to talk about simplifying expressions that have square roots in them. So let's move on. I have a quick review for you here. So it says, what is the square root of 9, 64, and 144? So answer those three questions now. We're going to go into some vocabulary. So for our index, that is going to be the number that's out front. If there's no number there, it's automatically a 2. So when you're looking at a square root, that's a square root because there's no number there. And that squared means 2. If there was a 3 out here, so let's put a 3 in that box. So if there's a 3 there, it's called a cubed root because cubed means 3, and this is our root. And that's called our index there. This sign right here is called our radical sign. And so we have our 3, which is our index, and then our radical sign. A lot of times we just call that our root. Our last part, our last vocabulary word is the radicate, and that's the number inside of our radical sign. So for example, if we had our index of 3 and then our radical sign, and then I had the number 8, for example, I'm looking for the cube root of 8. And so that's telling me that I'm going to have some number times some number times some number, and it equals 8. The first couple of numbers of this you should have memorized, but you will have a cheat sheet that's going to tell you that 2 times 2 times 2 gives you 8. And so the answer for this problem here is 2, because 2 times 2 gives me a 4, 4 times 2 gives me an 8. And that's my answer. Make sure you copy down those vocabulary words, and we are moving on. So we talked about this before, what each of the signs means. So if you already have this in your 7.1 notes from before, don't write it again, just listen to me. So we've got 3 different options. We could have a positive square root, which means that there's no sign out front. If there's no sign, we automatically know that it's going to be a positive sign. We could have a negative square root, and so there's a negative sign out front. Notice how a positive square root gives you a positive answer, and a negative square root gives you a negative answer. You could also have both square roots. So like we talked about before, if you have a positive sign over a negative sign, it's either positive or negative. So that saves us from writing so much. So technically, you could write a positive 4 and then say and negative 4. But mathematicians are lazy. We want the easy way out. That's the easy way out. And then just so you know, this is kind of important. It's impossible for the radicate to be negative in a square root. And that's because you can't multiply 2 negative numbers or 2 of the same number and get a negative. So if I said the square root of negative 4, that's impossible. Because if I said 2 times 2, same number, 2 and 2, that gives me a positive 4. If I said negative 2 times negative 2, that gives me a positive 4 again, because I have to do 2 numbers that are the exact same. Either way I do it, it gives me a positive 4. I'm never going to get a negative 4 like I want. And so that is an impossible answer. You'll actually dive a little bit more in depth into how to write that out when you're in high school. But for 8th grade, just know that you're not able to do it yet. So let's talk about a little bit more of what signs mean. Especially on your quizzes and your tests, and then some in your homework, you're going to see a square root and a squared next to each other. Those two things are inverses of each other, which means they undo each other, like how adding and subtracting does. So if I said I have 10 plus 2 and then minus 2, since I said plus 2 and minus 2, those two undo each other, and I'm just left with my starting number, which was 10. So if I'm looking at these two problems here, I've got the square root of 17 squared. Like I said before, they're inverses of each other, which means that they undo each other. And so my answer for this is just 17, because those cancel each other out. For this problem here, we've got a little bit more because I said minus 2. So what we're going to do is we're going to solve this part first. I noticed that we have a squared and a square root. Those are inverses, they undo each other, so we're just left with 52. We still have our minus 2. 52 minus 2 gives me 50. So that's how you're going to simplify those expressions. So go ahead and try those two problems. So pause the video and give it a go. So for that top one, you should have ended up with just a positive 65. And for that second one, you should have ended up with 20 plus 9, which gives you 29. And so those are your two answers, 65 and 29. We talked about this last time, but I just wanted to make sure that you guys understood this. Whenever you see a square root of a fraction, you're going to find the square root of the numerator and of the denominator. So when I'm looking at this problem, I'm seeing it like this. So I'm seeing the square root of 4 over the square root of 9. Square root of 4, I know, is 2. Square root of 9 is 3. And that's my final answer. So go ahead and try that problem there. Figure out what the square root of 136 is. Hopefully you ended up with 1 over 6. 1/6 is your answer. So now we're going to talk about estimating square roots. So we have not talked about this before. This is going to be a little bit harder than what you have been working with because perfect square roots are super easy. It's just memorization. So in order to figure out what our square root is if it's not perfect, so a perfect square root is like 36 because 6 times 6 equals 36. But if I said what is the square root of 35, I can't think of two numbers off the top of my head that I could multiply together to equal 35. And so we're going to have to estimate our square root for that. So we're going to figure out which perfect square roots the number is between. So if I'm thinking about my square root of 35 example, square root of 35, I know that the square root of 35 is going to be between the square root of 36 and the square root of 25 because those two are perfect square roots. 6 times 6 equals 36 and 5 times 5 equals 25. So I know it's going to be between 5 and 6, this square root here. And so we're just going to guess and check until we find the nearest 10th. So let's go ahead and try this problem here. So we're asking ourselves, what is the square root of 19? So the first thing we're going to do is we're going to figure out what two perfect square roots it's between. So the square root of 16 is 4 because 4 times 4 equals 16. and the square root of 25 is 5 because 5 times 5 equals 25. And so since I know that 19 is between 16 and 25, I know that the square root of 19 is going to be greater than 4 and less than 5. So we're always going to start off in the middle. So I'm going to start off by guessing 4.5. So we can automatically know what that first number is by looking at what two perfect square roots it's between. And then we're always going to guess 0.5. What we're going to do is we're going to open up our calculator. So I've got my calculator over on my right side here. And I'm going to type in 4.5 times 4.5. My calculator is telling me that it is 20.25. So I'm going to look back at the number. I'm looking at 19. This number is too big. So since that number is too big, I know that I have to go smaller. So I was at 4.5. How about we try 4.3? We'll go down 2. So in my calculator, I'm typing 4.3 times 4.3, and I end up with 18.49. Well, that number's really close, but right now it's still too small. So let's go ahead and try 4.4 and see if it goes too big or if it's still smaller. So in my calculator, 4.4 times 4.4, and that gives me 19.36. Well, that got too big because it's over 19. So I know for sure that since I'm rounding to the nearest tenth, all I need is that number there. We want the biggest number that is still smaller than our square root. So this is too big, or too small, whoops. So that is too big because it's over 19, so that doesn't work. And then this one's too small, but it's gonna be the biggest number possible before we go too big. And so 4.3 is going to be our answer. So why don't you try this problem? You're estimating the square root of 32. So figure out what two perfect square roots that's between, and then guess whatever it is, 0.5, and just keep going down until you get what the 10th is. So go ahead and try it out. So hopefully you got 5.6, and this is my explanation on how I got 5.6. So I know that it's going to be between 5 and 6, so it's going to be 5 point something because of the two perfect square roots it's between. I started off with 5.5 like we always should, and that was too small. So I went 2 up and I tried 5.7, and that was just a little bit too big. So I went down 1, just double checked it to make sure, and it was 31.36, which was too small, but it's the closest number that we have because 5.7 is too big. So we're going to go with 5.6, and that's our answer. Last thing I'm going to talk about is simplifying expressions. We kind of hit on this a little bit, but we didn't go as fully as I wanted to. So I'm going to give you expressions like this on your test. What you're going to do is anytime you see a square root symbol, you're going to treat it like a grouping symbol or like parentheses. So you do that first. So I see a square root on number 1 right there with my 150 and minus 6. So I'm going to do that first. 150 minus 6 is going to give me 144. And then I'm going to copy down the rest of the problem. 13 to the second power. Now I'm going to simplify my, my squared right there for the square root of 13 to the second power. Since I know that a square root and a squared are inverses of each other, that means they cancel each other out, which just leaves us with a positive 13. I'm going to also simplify this part here. So I know, because I can look at my paper and I can see that the square root of 144 is 12. So this all simplifies to 12 plus 13, which is easy for me to do. We learned that in like first grade, and that's 25. So 25 is my final answer for that first problem. For my second problem, again, think of square root symbols like parentheses. So we're going to do our square roots first. So I'm looking at the square root of 36, and I'm looking at the square root of 81. So the square root of 36 is 6, because 6 times 6 is 36. Square root of 81 is 9, because 9 times 9 is 81. I'm going to copy down my subtraction sign, and then I've got a 3 out front still, which means that I'm going to put my 3 out front like that. And so I'm going to keep that 6 in the parentheses, because that right there is multiplication. So 3 times 6 minus 9 is what I simplified to. I'm going to follow my order of operations and do my multiplication division first. So since I have multiplication right there, I'm going to do 3 times 6, which is 18. Copy down my minus 9, and I can do that pretty quickly. 18 minus 9 is just 9. So 9 is going to be my final answer for number 2. So go ahead and try those 2 problems there. They're very similar to the 2 problems that I did. So pause the video and try out those 2 problems. There's your 2 answers for problems number 1 and 2 of the You Try These. For number 1, you should have gotten 12, and this is my explanation on why. For number 2, you should have gotten 9, and that's my explanation on why. If you have any questions over this lesson, please send me an email.